Good day, students. Welcome back to my channel. Please do not forget to like and subscribe. For today's lesson, we are rationalizing the denominator. A radical is not considered simplified if there is a radical number in the denominator, or if the radicand is in a fraction. The process of eliminating the radical in the denominator or a fraction in the radicand is called rationalization. To rationalize the denominator of the radical expression, multiply the numerator and denominator by the expressions of the lowest power that will make the denominator a perfect nth power. Let's have examples. Simplify the following. Number 1, 4 over square root of 2. We multiply both numerator and denominator to square root of 2 to eliminate the square root of 2 or the square root sign in the denominator. So it will make 4 all over square root of 2 times square root of 2 all over square root of 2. Remember, in multiplying a fraction, we need to multiply numerator to numerator and then denominator to denominator. So first, we have 4 times square root of 2. Since 4 is a whole number and 2 is in a radical sign, it will become 4 square root of 2. And then, square root of 2 multiplied to square root of 2. Since they are both inside the radical sign, we can now multiply them. It will be 2 times 2, and that is 4. Then, copy the radical sign. So, it will become 4 square root of 2 all over square root of 4. Let's simplify square root of 4 in the denominator. So, copy the numerator, 4 square root of 2, all over the square root of 4 is equal to 2. So, it will become 4 square root of 2 all over 2. Since 4 is a whole number and it is divisible by denominator 2, we can divide it. 4 divided by 2, the answer is 2. So, the final answer for that will be 2 square root of 2. That means to simplify 4 over square root of 2, and that is 2 square root of 2. Given in number 2, we have square root of 2 all over square root of 5. The denominator is in a radical sign, which is square root of 5. So we multiply both the numerator and denominator to square root of 5. So we have square root of 2 all over square root of 5 times square root of 5 all over square root of 5. Multiplying the denominator, multiplying the numerator to numerator, it is square root of 2 times square root of 5. Since they are both inside the radical sign, 2 times 5, it will be square root of 10. And then on the denominator, square root of 5 times square root of 5, and that is square root of 25. By simplifying that, square root of 10 is already simplified. So it will become square root of 10 all over the square root of 25, which is 5. Take note, we cannot divide or simplify 10 to 5 because 10 is inside the radical sign. For that, the final answer will be square root of 10 all over 5. That means square root of 2 all over square root of 5. The simplest form of that is square root of 10 all over 5. Next, number 3, square root of 2x all over square root of 3y. So, since the denominator is square root of 3y, we multiply both numerator and denominator to square root of 3y. So, it will become square root of 2x all over square root of 3y multiplied to square root of 3y all over square root of 3y. Multiplying the numerator to numerator, square root of 2x times square root of 3y, and that is square root of 6xy. Since 2 times 3 is 6, and then copy x and y. On the denominator, square root of 3y times square root of 3y. 3 times 3 is 9. Then y times y is y squared. Simplifying that, square root of 6xy is already simplified. So, we just need to copy that. And then square root of 9 is 3. And then square root of y squared is y. So, for that, we have square root of 6xy all over 3y. Again, we cannot divide 6 to 3 because 6 is inside the radical sign. So, for the final answer, we have square root of 6xy all over 3y. So, square root of 2x all over square root of 3y is simplified as square root of 6xy all over 3y. Given in number 4, we have the cube root of 3 all over the cube root of 4. We all know that cube root of 4 is also cube root of 2 squared. So, we still have 1 square root of 2 to make the exponent as 3. So, we multiply both denominator and numerator to cube root of 2. Simplifying that, we have the cube root of 3 all over the cube root of 2 squared times the cube root of 2 all over the cube root of 2. By simplifying that, numerator to numerator, 3 times 2, the answer is 6. And then, 2 times 2 is 4, 4 times 2 is 8. That will become cube root of 6 all over cube root of 8. Simplifying the numerator, cube root of 6, it is already simplified. And then cube root of 8 is equal to 2 because 2 times 2 is 4 times 2 is 8. So, for the final answer of this, we have the cube root of 6 all over 2. That means cube root of 3 all over cube root of 4 is simplified as cube root of 6 all over 2. Next, number 5, we have the cube root of 4 all over the cube root of 9x squared y. We all know that 9 is also equal to 3 squared. So, we have cube root of 4 all over the cube root of 3 squared x squared y squared. Multiply. So, we need 1 more 3, 1 more x, and 2 more y. So, we multiply both numerator and denominator to cube root of 3 x y squared all over 3 cube root of 3 x y squared. Simplifying that, 4 times 3, the answer is 12. So, it will become cube root of 12 xy squared all over 3 is 3 cube because 3 squared times 3, it will become 3 cube. X squared times x, it will become x cube. Y times y squared, it will become y cube. By simplifying that, the numerator is already simplified. So, copy cube root of 12 xy squared all over 3xy. So, for the final answer, we have the cube root of 12xy squared all over 3xy. In simplifying, 3 cube root of 4 all over cube root of 9x squared y. That is cube root of 12xy squared all over 3y. Remember this. When rationalizing the denominator, the value of the expression does not change. Only the form of the expression changes. When we rationalize the denominator, we make the denominator of the expression rationalize. Thank you for listening. God bless.